Alright, so here we are at Peter Horwood's farm at Mingenew in a pit with a deep yellow sand. Now these soils are quite common up through the sand plain here, of course, in the northern part of the grain belt, and they also occur further south and on the south coast. The typical thing about a sand, of course, is that it doesn't hold much clay, and because it doesn't hold much clay, the water holding capacity and nutrient holding capacity per unit depth is relatively low, and some places in the world won't farm this kind of soil. But these deep sands compensate for that low water holding capacity by having greater depth for access to the roots. And there are cases where in research we found crop roots as deep as 3 meters on these kinds of soils. One benefit of this low clay content on these sands is that it lets the water in very easily when there is a higher rainfall, and the rainfall can penetrate to depth. On some heavier soils, and particularly heavy clays, a heavy rain may run off because the water can't be accepted into the profile so easily. However, in these wetter years, when there's mobile nutrients like nitrogen, potassium and sulfur even can move down through the profile, and the roots can't get to them so easily, and the farming here has to add those nutrients during the growing season to compensate for that. And when nitrates leach from this topsoil, what happens is that they'll leave a hydrogen ion behind, which is basically acidity. So the leaching of nitrates out of these soils accelerates the acidification of the topsoils and requires the farming system to apply more carbonates and such things to compensate for that. These soils will also acidify the subsoils relatively easily, partly because these subsoils don't have a lot of potassium. And what happens is that the crop roots exude organic acids to try and get hold of more potassium, and that organic acid helps to acidify these subsoil layers. When the pH gets low enough, this can release aluminium into the soil solution, toxic aluminium, which will impair the growth of crop roots and become a constraint to its access to moisture and nutrients. The other complication in these soils, brought on by the low clay content, is that the plants, all the crops and pastures, produce organic matter which decomposes and partly produces wax which can coat the sand grains and prevent water penetrating through the surface. Now, non-wetting can leave dry patches in the topsoil where crop doesn't germinate and also where nutrients aren't available. The other feature of these sands, they're used to form the house pad to build houses on. They're very easy to compact when they're moist. They're some of the most compactable soils that are farmed in this area. So what happens when a really heavy wheel runs over here, it squeezes this sand, the moist sand, together and makes it so tight that roots may not be able to penetrate very well, or even may not be able to penetrate at all, and in worst cases the aeration of that soil can be poor as well. And as the machinery being used in farming has increased in weight, then the depth of these pans and the strength of these hard pans has increased. When they slow the roots down, the roots can't keep up with those moving nutrients like nitrate and potash, and that increases the acidification of these soils too. And when they can't access below the depth of a pan, they can't use the moisture in there, and they may yield less. Well, the other issue that can happen in wet conditions and with tight traffic pans is waterlogging. Not so much in this district, there's not often there's enough rain, but down on the Esperance sand plain where it rains more, it's been very common to find water ponded above these pans, even into the topsoil, and that waterlogging has taken all the air out of the soil, and the roots can't grow much deeper than this. So in general you can see that there's an acidity, a non-wetting and a compaction problem commonly in these deep sands, which needs to be managed. There are ways of doing that. They usually involve deep cultivation, deep ripping, deep tillage to do some breakup and mixing in of carbonates and even the topsoil. And they involve better management of the surface to usually make furrows to help the moisture go in the right place. But when you do all these things and you combine all this expense, you want the benefits to last as long as possible. So there's a system called controlled traffic farming, which will tend to put all the heavy wheels in one place, and that becomes an internal road, which is very firm, and you use less fuel to run on it. And it doesn't recompact these zones you've improved, and they will continue benefiting the farm for longer, and therefore the investment you make on that initial improvement will last for longer, and the net improvement to the farm income will be increased. But all these things take time to develop, and they all need a good plan.